Right. In example 4, what we're going to do is we're going to find some different probabilities. We're going to find the probability of an event happening and find the probability of an event given that something has happened first, and then we're going to compare those to determine whether or not events are independent or dependent. Before we get to that, just kind of looking at this picture. So what we see here is a picture or image of all of the different cards in a deck of cards. Looking at the way I have these labeled, on the actual paper itself, it's a little bit more difficult to see. So notice that the first red are black, the second red that's a little bit more grayed are red cards. We have another row of black cards, another row of red cards. And then our cards go everything from ace, which has the 1, to the 10, and then we have our jack, queen, and king for both. So again, the image isn't perfect, but this should, if you're a visual person, make it a little bit easier to find some of your probabilities. This will also be something that's included on the formula sheet for this chapter, so that way you don't have to memorize all the cards in a deck if you're, again, more visual, or even if you know all the cards in the deck but it's easier for you to look at the picture, you will have that available to you as you're going through and working on the test if you do print either this page out or the formula page that you're going to get. Alright, so what we're asked in our first example, are the events the card is a diamond and the card is red independent? Explain. Alright, so first we need to find the probability that the card is a diamond. Alright, so looking at these shapes, I'll go through and I'll label these as well. So what we have here, right, this top shape here, we call a spade. Right, this one that has the 3 pieces to it, we call a club. The red ones are a little easier to pick out. We have hearts and diamonds. All right, so in case you're not as familiar with the card terminology, there is that as well for you. All right, so first find the probability that a card is a diamond. Well, if we look at our picture, we see that we have a row of diamonds. If we were to count these, we have exactly 13 cards in this row. So we're going to take 13 divided by our total, which is 52. This is going to reduce to 1/4. And I'm just going to leave these as fractions in this case. All right, second, find the probability that the card is a diamond given the probability that the card is a red card. All right, so we still have 13 diamonds, which are all red. But now if we divide it by the number of red cards, we have 2 rows of red cards up here. All right, so we only have 26 red cards. Only half of our deck is red. All right, this gives us 1/2. All right, then how we're going to use this to decide whether or not our events are independent. Are the events independent? We are going to say no. The probabilities P of D and P of D given R are not equal. So we compare our answers from A and B. They're not the same, so they are not equal. Right, so now let's do another one. Are the events the card is an ace and the card is a diamond independent? Right, so the card is an ace. Ace, again, is another name for all of our ones that have just one single shape on them. So the probability that the card is an ace is 4/52. If we reduce that as a fraction, we get 1/13. Right, the probability that the card is an ace, given that it is a diamond. Right. So now we're going to go up here and we're going to restrict ourselves just to our diamond row. And we have exactly 1 ace of diamonds. So our probability down here is going to be just 1/13. Are the events independent? And we're going to say yes. The probabilities P of A and P of A given D are equal. Right, so if you're asked to test whether or not something is independent or dependent mathematically, right? What we're looking for here, what we're using, right, is these comparing our two different probabilities and determining whether or not those are equal.